Today we're going to be joined by me, Ben Davenport at GoEngineer, and our team at PostProcess, specifically Mark, who's going to be able to answer your questions regarding the PostProcess technology. All righty, to get started, what is PostProcess? So the one thing about PostProcess is we have some issues in our manufacturing chain. Usually when it comes to traditionally working with 3D printing parts is that we have a lot of steps involved regarding post-process. There's a lot of cleanup involved and a lot of manual work that we need to do. So within this regard, post-process has a verified solution. And what that is be able to automate this process into an easier and more efficient path, where we can take basically any type of technology regarding FDM, DLP, SAF, or PolyJet, or even resin, and be able to clean them efficiently with solutions that are safe for the workplace. Within that, we can have many different options with this. Is that obviously we have improved safety with our standards. We have, and we are able to reduce our labor costs up to 10 to 30 weeks with our ROI. This is, after working with these machines, I would say that we use them on a daily basis, and the efficiency speaks for themselves. We're able to work with a lot of parts and are able to process parts quickly so that we can get them out to our customers. Some of these things that we are critical is our safety. They have a low odor. They reduce less waste. The machine that we have here, we only change out the resin every 6 months to a year, and we have compatibility with our ISO compliant biocompatibility as well. And obviously we have quicker cycle times so that we can have consistent results, so that once we have a chemistry for one technology and material, we're able to repeat that and make our efficiency better. Within this, we have multiple machines regarding different technologies, such as our resin support, material, and our finishing. What you can find here is that they range in a wide range of different sizes and capabilities, but they do pretty much all the same thing within regard to help with efficiency and support. So I'll basically, after this, I'll take this away and show you the resin and support removal solutions, where we will have show off our 520, our 800, and our 400 series. And obviously you can see in the bottom here, you can see a wide range of supported technologies that they can support, including all the way up to SLA to PolyJet. So without further ado, I'm going to add Mark in the chat, and he's going to go over the different technologies firsthand and give you a firsthand look at how they work and how they function, and talk a little bit more about them.
Thanks, Ben. Hi, everybody. Welcome to our lab in Buffalo, New York. I'm standing in front of some of our SVC lineup here. We're going to cover the DEMI 830 first, and then we'll move on to some of the newer systems over that way. But looking at the schematic on your screen now, this is just reviewing how the inner workings of the SVC systems operate. So what you can see on the diagram, there's a pump flow that creates a vortex flow in the solvent itself. This specific unit, the 830, does have ultrasonics as well. And then there is software that lets you control exactly how everything is operated. But just to give you a look inside the processing chamber, this specific system, the 830, has an 18 by 18 inch by 18 inch deep processing area. This is just kind of a basic fixture that we use. There are other options that are enclosed if you need it. This system right now is set up for resin removal, but could also be used for both PolyJet and FDM parts. And then just to give you a quick look, I'm going to go into the manual area of the software and turn the pump on, and you can kind of take a look at the flow that is going to result in the processing area. So one of the big benefits here is the solvent itself. So again, this one currently is set up for resin removal. So the solvent is going to be our PLM 403 sub. The benefit of that versus maybe your existing IPA use is that it's going to stay in liquid form. Its flash point is well over 200 Fahrenheit. So you don't have to worry about it flashing up into the operator area. So quite a bit safer to use. And you can also ramp up the temperature for those trickier resins that might be a bit more viscous. Okay, and if we move on to the next slide. So this is just going to give an example of kind of our typical change that we see. So again, speaking just to resin removal, that traditional process is typically going to be with IPA. And that 20 minutes is, you can see half of that being manual technician time, because in most cases, it's an operator who is physically moving parts around in first a dirty IPA bath and then moving it to a clean IPA bath. There's lots of tech time in keeping that IPA updated, as well as obviously manually moving the parts from one step to the other. This system, and then all the other different sized SVC units, it's one step. So they go into the system for 10 minutes, you pull them out, rinse them and dry them, and they're done. So it's a significant time savings. Okay, next slide. So this is an actual example, and this one is related to the 520. So I'm going to kind of scoot over to that 520 unit here. Now the main difference with this, as you can probably see, is it is enclosed and there's a lift attached. The lift that's in there now is kind of our generic resin removal fixture. So that's just sitting on these forks here, which allows it to be lifted in and out of the solvent. But the example you see there is for a dental customer. And what it's showing is that you can run multiple resins, sometimes all at the same time, if they can all handle the same temperature. And you can see the cycle time on that slide over there, less than 10 minutes. So this one was 7 to 8 minutes of actual processing time in solution. And then they're just pulled out and rinsed in our AUX 400 solution, which is just going to be in a separate vessel. So it's just a quick dunk. And all that's doing is removing the 403 detergent from the parts so that they can dry a lot more quickly. But that is a very typical resin cycle that you see on the other screen there. So almost always under 10 minutes. I've got a quick question that came up. How many models can I run at a time approximately? So speaking specifically to dental models in this system, generally I'd say kind of cap it at 50 to 60 parts. There is a divider in here, so you can kind of put 25, 30 on each top and bottom, just to kind of keep them from piling up on top of each other. But 50 to 60 models at a time in that 10 minutes or less cycle is going to be pretty standard. Okay, we can move to the next slide.
This one's me. So we also are going to be talking about our Automat 3D. This is basically our integrated software platform to be able to use the machines, program them, and not only that, manually control them. What's really nice about this program is that we're able to actually put in multiple different profiles so that we are able to do custom profiles for various different types of materials for the printers. What's also great about this is that once when we have the profile saved, we can just basically add it to our bank, and then so that we can go back to it later. We're actually able to upload about over hundreds of profiles. So if you're working with multiple materials or even with multiple people, they can go to the correct profile and just hit go and be ready on their way to post-processing their part. So with the next slide, I'll take it over to Matt.
All right, so this is just going to be kind of a more in-depth look at what I mentioned before with the comparison of our 403 detergent, and there's some other common solvents, but IPA is the one highlighted there. So the main takeaway is that you can get a lot more resin by weight in solution in the 403 versus IPA, which is going to be a lot less changing of detergent. So you can see the bottom graphic there just shows it by volume. Our average user of this specific system, they're changing out the 24 gallons of solution in here, typically once or twice a year. The really high volume users, maybe more like once a quarter. But in any case, it's much longer periods of time versus just using IPA as the solvent. I see another question in there that's kind of more related to software, so I can cover that as well. So the software itself, we can kind of get a better look at here. So this is something that will be completely covered when the system gets installed. We'll train the operator on how to use it, but the basic idea is that there's a few different screens. You're typically going to be operating in the automated area. And what that's going to show is this is where you're going to set up your actual cycle. So the 520 specifically does have a variable speed pump. So if you have more delicate parts, you can run it a lot more slowly. If you have stronger parts that you're not worried about, you can really crank up the pump speed, which will decrease your cycle time, which is down to the bottom right. There's also obviously temperature. So that's going to be dependent on the resin that you're using. There is a little guideline up top that's just by viscosity. So, based on your viscosity, you want to operate at X temperature. And then the other option here is the drop down. So that is for the Z height setting of the lift. I actually have this fixture in there at the moment, so I'll select that enclosed fixture option. And I will just run through a quick cycle so you can see the actual operation. I did have the door open and now I've closed it. So you do have to hit the safety reset button. So that blinking red light, once I push that, will turn to a blinking green light. And then I can go ahead and start the cycle, and I'll give you a look inside the machine so you can see exactly what's happening. But you can see the first step, it drops down into solution. And then once it's fully seated all the way down there, the pump will start and you'll be able to see the pump flow that's occurring in there. And at the moment it's set to 75%. So you can see rather aggressive pump flow. You can crank that up even further, once you have that fixture loaded up with parts. So it can accommodate a lot of volume of parts just because the pump can kind of overcome being blocked because the flow options that you have there. If you do need them. But again, if you're only running a handful of parts, you can really back off on the speed. And then once it stops, it's just going to automatically raise out of solution and be ready for the operator to pull it out of the Demi X520 here. Okay. Next slide. And then we can move on one more. So this is, again, just the overview of 403, and then going into now the biocompatibility of it. And I believe this one is going to be Ben.
Yes, sir, it is. So, yep, we do. PostProcess does offer a biocompatibility formula so that when you are working with a surgical app, when you're working with parts that need to be within that realm of application, we can satisfy that need. This helps a lot of our customers within this application to be able to keep within the standards. And obviously, we do have documentation to be able to support that. So that's another great thing that we feel at GoEngineer that gives our customers an option within that market. So after that, we'll give next slide. And I believe this is Mark.
Yep. So something I've neglected to mention so far, we do, when we're talking resin, have a lot of workflow documentation, and there's an example on the slide over there. So dependent on the resin you have, we most likely do have an existing workflow, which is going to tell you the temperature to set the cycle to, the expected time, some other parameters that you need to set for the machine, depending on which one you're working with. So you don't have to start from nothing. We generally have a good starting point for you on a variety of resins. I do see another question that popped up. This is going to apply to both the 520 that I was at and now the 830 that I'm in front of here. Is there any special equipment needed to change out the detergent? So no, we do provide everything you need. So the 520, for example, does come with a pump to help fill the detergent from the front. And then this system and the 520 are both going to be gravity draining just from the front of the system. So there's a ball valve on the front, it's on the side on the 520, but that's just going to be drained back into the 5-gallon jerry cans that your detergent arrived in. So it's a rather simple operation. So yeah, no special equipment needed. Okay, next slide.
PolyJet support removal. So we do also, like I was mentioning earlier in the presentation, we do also are able to clean PolyJet parts. We have solutions to be able to make this as clean as possible and as efficient as possible. And not only that, we are able to have a lot of parts compared to a DEMI 400 and all the way up to a DEMI 800 with a larger capacity. So if you're working with a lot of parts that need to be dissolved very quickly with a solution that doesn't need to be changed doesn't need to be changed often, then this is a great application as well. So I believe we can have the next slide would be as an example. You can see this throughput where we are able to dissolve up to 80% more faster than other methods. This is critical for that if you're running a lot of PolyJet parts and you need to out those parts out the door as fast as possible. This is a very good solution for our customers. And you can see the complex model there, of a spine. I'm not sure if that's the bottom lumbar or the top lumbar. But at the end of the day, you can see it has a lot of support. It was printed in matte, so it's fully covering the model. But after putting it through either the DEMI 400 or the DEMI 800, it was able to fully clean that part efficiently. The one thing about spines is there's a lot of nooks and crannies and inside of there, which it is able to clean, get inside and clean efficiently. So we'll go to the next slide. And then the other thing is that because we're able to control all the everything when it comes to the flow rate, agitation, and things like that within the machines, if we're working with very thin features or small cavities, we're able to get inside of them efficiently without hurting the part. I've run many parts through our machine, and I would say it does a really good job of cleaning out very, very tiny holes to be able to get in those nooks and crannies. One thing about PolyJet is that there will be a lot of nooks and crannies, so this technology gives us the ability to efficiently get that through. Next slide. I believe this is Mark.
It is, yeah, and this is going to be an example that I actually have in front of me. So we saw the slide with the spine, but this was one that I just did recently. So you can see the before, very heavy PolyJet supports all the way through there. And then I've got the after example. So as you know, seeing all the nooks and crannies that Ben mentioned, fully cleaned out on the after. I don't know if you can read the timing on the screen there, but that full cycle was done in a 430. So the slightly smaller version of what I'm standing in front of, but same principle, done in 2.5 hours. So that's almost completely automated. There was one step at the 30-minute mark where it was pulled out and then just minor bulk removal was done to kind of help it along. And then it was placed back into the system for that remaining 2 hours. And it came out, rinsed and dried, fully clean. So this is just a way to completely automate this process. So you're not sitting there for 20, 30 minutes water jetting all of that support off. It can just be chemically removed and in large batches as well. So you're not doing one at a time in here. You can fit many of these parts at once.
All right, we'll go to the next slide.
Yep, I do have a question that popped in quickly. It'll actually be kind of apparent for multiple pieces of equipment here, but are there any special requirements for setting this equipment up in my lab? It will depend on what we're referring to. So the whole SVC lineup, which is from the 520 that we talked about first, the 430 and the 830, those do come in 120 volt options. The 830 also is a 240 single phase. So that's all they need is the electrical connection. Some of the larger equipment, which we'll talk about next, in addition to the electrical, will also need water connections. But as far as SVC goes, electrical only.
Perfect. All right. If there's no more questions, we'll go to the FDM, which actually is a great segue. So in our FDM side, we have the base model. This is a very large machine that is very capable of be able to post-process very large FDM parts with a very, very unique technique. So without that, I will go to the next slide and let Mark take it away. So better show it off.
Yep, thanks, Ben. So yeah, I'm standing in front of the base, but you've also got a schematic of the look of the inside of it. I can't actually show the real thing. So you'll notice that it's quite a bit different than most FDM processing techniques. So on this system, you're going to have some spray nozzles down below where the parts will be processed. And then up on the ceiling, there's spray nozzles that will spray down as well. So you can see kind of the flow rate on that other slide. The basic idea, though, is that we're really reducing the cycle time because of that spraying action. In addition to the nozzles I talked about, there's also these flex nozzle options. So if you do have parts that have kind of complex internals, like this specific part does, you can direct the flow exactly where you want it to go with those flex nozzle options. Then if we go to the next slide, I believe we'll have so this is just kind of going to be a demonstration of, again, what I just spoke about, the comparison. So generally, the part that you're looking at on the screen, a single one of those would take 6 to 8 hours if you're submerging it in sodium hydroxide, which is kind of the standard go-to method of dissolving soluble Stratasys supports. In comparison, it's going to be less than an hour in the base. So it's a huge time cut to the cycle. And then obviously you have a lot of room to process a lot of them all at the same time. So really drastically reducing your cycle time and you're increasing that throughput. Okay, and then this is just a quick overview of the support materials that we can work with. It's essentially just going to be all soluble Stratasys supports. So anything Stratasys lists as soluble for FDM can go into the base. So this is the performance eval of the part that I've got in the machine here. So you can see it's rather complex. The before, you can see the external supports, but more importantly, the internal supports, which is generally what's going to take the most time to kind of fully clean out. But because I was able to use that flex nozzle, at the same time the outside supports were getting dissolved, those internals went pretty quickly as well. And that part was done in just 45 minutes. So, compare that to a tank where I would estimate it's going to be, again, more like 6 to 8 hours, if not longer. So really cutting down on the time. You can see the temperature listed there was 145 Fahrenheit, which is going to be pretty standard for most applications in the base. Okay. And then this is just a case study, specific example. This part, I know it's hard to determine scale, but it's very large. So it's probably close to a meter in length. And then obviously that tank is fully filled with SR30 support material. So this is just kind of outlining the drastic difference compared to the old method that this customer was using to now using the base, and how much time they were able to save and how much more quickly they can move that part kind of through its process and getting to the next step of prototyping. So just one example of many of people using the base to kind of speed up that overall flow.